All right, so we're on part 2. So on part 2, we're going to divide our page into 6. Some equalish spaces. This is not drawn to scale. If you would like to draw the 6 as you go, that works perfectly well. Just know that there's roughly 6 parts. Yep. It's supposed to be straight lines, Rachel. Thank you for pointing out my lines aren't straight. Yeah. Yeah, it's okay. Did you say, is it supposed to be diagonal? You knew they were straight. Yes, you did. It's okay. All right. So do not write yet. I'm going to tell you what to write in box 1. But, so what is the inverse operation of exponentiating? We were estimating. The inverse is called taking the log. So it is taking the logarithm, or taking a log is what we're doing. That is the inverse operation of an exponential, and therefore the inverse of a log is a exponential. Okay. What we were doing was estimating our exponent, right? And now we're going to talk about how to find the exact and the approximate value. All right. In your box 1, you're going to write down our 2x equals 9. Okay. So this is our original problem that we've been working with, right? Problem number 6. Looks familiar? Okay. So we have 2x equals 9. These are the steps that we're going to take to find the exact followed by the approximate value. Okay. So we've done estimate. Now we're going to do exact and approximate. Got it? All right. So this is our problem. The first thing that we do is we take the log of both sides. Okay. When you're taking the log of both sides, your log is going to be made up of the same base that your exponent is. So do we see how our exponent has a base of 2? Our log is going to have a base of 2. Does that make sense? So what I do to one side, I do to the other. So that's step 1 and solve. You can, you either can write the words or write the example, or whichever one you may need in your heart. In box 1. We're in box 1. Okay. Our next step, step 2, is to simplify, to clean it up. The log undoes the exponent. So it's essentially is going to set our power free. Let me be free. Yes. That's what it does. It sets it free. Okay. So the log sets the power free. And this right here is our exact answer. Huh? Because the original problem was 9. So that's our exact answer. X equals log base 2 of 9. Because we set it free, it's by itself. And then the third step is to find the approximate answer. To find the approximate answer, you type it in the calculator. Input into calculator. And then we get our approximate answer. Ta-da! Notice that it's an approximation, so it doesn't have the equal sign. It has the little waves, the approximation. We're going to go over that. We're going to go over that. Okay? So our exact has the equal sign. Our approximate has the waves, right? Got it? 3 steps. How do we feel? Are we ready to see it action in the calculator? Because that's the last part. If you're using my preferred method, which is Sylvie and her grandkids, here's Sylvie. In Sylvie, to type it in, you're going to press alpha window, and it'll say log base. And then you just type it in, log 2 9. And hit enter. And there's your approximate value. Okay, huh? I surely can. You're going to press alpha, window, 5, and you're going to type in, and there's your approximate. My Sylvie right now is already set to round. So in case you're wondering why it's rounding, she's set to round. To make yours also round, you press mode, and you see where it says float. You want to change your float to the number of decimal places you need. And I need 3 decimal places. So I set her to that, and therefore she does all the rounding. Okay, how do we feel? If you forget about alpha window, Sylvie's safety net for all things that you need is called math. You can scroll through math until you see it. And once you see it, you can click there. Okay, so if you forget, oh no, I don't know how to solve this math problem, on Sylvie, it's pressing the math button. Got it? All right, let's talk about you and your Desmos addiction. So for my students that are addicted to Desmos, let's look at Desmos. On Desmos, you're literally going to type out the word log, L-O-G. And then you're going to press Shift dash. So dash is the button next to 0. So you press Shift dash to put your base in. And then you arrow over and you put in whatever you need. And I need 9. Okay, I'll do it again. So on Desmos, you're going to press, type out L-O-G. You press Shift dash, type in your base, arrow over, and put in what you need. Okay? Questions, comments, concerns? Now, Desmos does not round for you. That is your responsibility. They're not as cool as Sylvie. All right, how do we feel about those steps? How do we feel about being able to take the exponent and find the value of our exponent? Yes? Doable? All right. All right. So do not write this down. This is just a whole summary of what we did. Got it? Do not write this down. This is just the summary page. Okay? So recapping what we said, solving exponents, we're going to make sure the exponent term is by itself, which ours was to begin with. You're going to take the log of the same base on both sides, correct? After I do that, it's going to set the power free, and that is my exact answer, correct? When the power is set free, that makes your exact. Agree? Okay, then you're going to input the log into the calculator. If you're using the handheld, you're going to press alpha window. If you forget, you can always go to math. If you're using Desmos, what do you have to do? Type it out, right? Type log and dash, shift dash and input. We're going to always approximate to 3 decimal places. Got it? How many decimal places? 3. Everybody with me? Anybody's like, I have no clue what you're talking about. Nope. All right. In our second box, we're going to have to write down the change of base rule. Okay? We're going to do the change of base rule. And we're going to talk about why change of base is important. So change of base formula was before you could put in what base you needed. I'm going to highlight what you need to write. You're writing where it says change of base and then the rule. In box 2. We're in box 2. So you're only writing what is highlighted. So this is a change of base formula. So a long time ago, you used to not be able to put the base in the calculator. And when you weren't able to put your base in the calculator, you had to type it in as 2 logs, the quotient of 2 logs. Okay? And the numerator, this is the log of your argument. And the denominator is the log of your base. It just creates a fraction. Okay? Natural log can be used as well, but natural log wasn't always on the calculator to begin with. Okay? But it can be used as well. So we have log of our base. Your base is always in the basement. Okay? The log of your base is in the basement. The log of your argument is in the air. Argument in the air, base in the basement. Argument in the air, base in the basement. Make sense? Okay, so for example, before we had the ability to put in log base 5 of 7, we had to put log 7 divided by log 5. This is also useful if you're doing your homework on the go. If you have a calculator of any sorts that is scientific, you can turn it into a log problem. So let's say you are in the car and you're doing your math homework. You're like, oh, dang it, I don't have a calculator. That's fine. Turn your phone sideways and use the scientific version of it. It's going to produce the same answer. So I'm going to model it with just a basic scientific calculator. I need the basic one, please. Here she goes. So here is a standard scientific calculator. Note it. Oh, or not. I was joking. Tricked you. Let's try that again. Here's a basic scientific calculator. And as you can see here, can I change the base of a log? I can't on here, can I? So if I wanted log base 5 of 7, I wouldn't be able to do it as is. I would have to do it in parts. On some calculators, you have to press the number first and then take the log. Divided by the number first and then take the log. And I hit enter, and it's going to say your approximate answer is 1.209. That works the same on all scientific basic function calculators. Anything that has a log, you use the change of base rule. Does that make sense? Yes? All right, that's change of base. I'm supposed to introduce it to you. Now you know it. Do we have to use it all the time? No, because we can put in our base. Does that make sense? So because we can put in our base, change of base isn't completely necessary for us. But it may be used if you are in a science class that only uses the scientific calculator and non-graphic calculator. All right, cool. Questions about change of base? All right, let's do our first example. So we're now in box 3. In box 3, we have 3 to the x equals 26. We're going to go through our steps to solve it. So step 1 is to make sure that your exponent is by itself. Is our exponent by itself? Yes, so I'm good to keep going. Step 2 is I'm going to take the log of the same base on both sides. So I'm going to take the log base 3 of 3. Why do I want to keep making it a big X? Let's try that again. 3 to the x equals log base 3 of 26. How do you feel about that? Okay, so step 2, done. Step 3 is we're going to set the power free. You're free, my little birdie. I took it out for you. So x equals log base 3 of 26. And this is my exact. If it asks for the exact, this is my exact. With me? All right. Step 4 is to plug it in the calculator. The calculator of your choice. That's going to give you your approximate. So I'm going to go, we all know I love Sylvie. So we're going to open up Sylvie. Turn her on. And I'm going to do alpha window 5. And it's log base 3 of 26. Hit enter. And I get that my approximate value is 2.966 or 2 in 966 thousandths. How do we feel? 2.97? Nope. It's 3 decimal places. 2.966. Yeah. Easy peasy. All right. Does anyone need me to do it again in decimals? Are we comfortable in decimals? We're good? Okay. Guess whose turn it is? All right, moving on to box number 4. So in box 4, write her down. We've already did this approximation, right? Before you get started, what has to be true? It has to be isolated. So make sure you isolate. All right. I walked around. For the most part, it seems like we're doing good. Hopefully clarified some things. Again, step 1 is to make sure that this guy is isolated. And since it was not, I had to subtract 1 from both sides. So we're actually working with 2x equals 29. We're going to take the log of both sides. The log base depends on the base of your exponent. The base of our exponent is 2. So log base 2 of 2 to the x equals log base 2 of 29. We set our power free, and we get our exact answer is x equals log base 2 of 29. That's our exact. Okay? We're going to plug in to find our approximate. So I'm going to go to my homegirl Sylvie. And I have alpha window 5, and I have log base 2 of 29. Hit enter. On our part 1, we approximated that x is between 4 and 5, but closer to 5. Were we correct? Yes, our x is 4 and 848 thousandths. Easy peasy. What things? A negative log? Your x can't be negative. Your y can, your x can. All right, let's see if you really got it. In box 5, here you go. This is what you'll do. See what happens. If you could do this, you can do anything. That's together. That's an exponent. Can't touch it until it's set free. Has it been set free yet? No. Can't do anything until it's set free. See, we're going to answer it. Is it about +1? Hold on, let me fix something. Checking my math. I wanted to check the math for my last problem that y'all have to do. Sorry. Making sure she wasn't a little Jackie, a little messed up. Stop. Okay. All right. You should have gotten as far as you can. Now let's talk about it. All right. So the step one is to make sure what? It's isolated. Your exponent is isolated. Is our exponent isolated? No. So we had to add 2. So now we're left with 3x plus 1 equals 102. Can't do anything. It's not free. Can't do anything. We got to free our power. How do we free our power? How do I free the power? Log. You have to take the log of the same base. I cannot touch anything that is a power until it is on the ground. So we have log base 3 of 3 to the x plus 1 equals log base 3 of 102. Okay, this sets my power free. So now my power comes down to the ground and I'm left with x plus 1 equals log base 3 of 102. And now I have to minus 1 because your x is not by itself, is it? So we subtract 1. So my exact answer is x equals log base 3 of 1. Oh my God, pen. I think it's time for me to change the little tip of my pen. She's doing the most. Minus 1. This is your exact. You can't combine them because they are not like terms. Okay, so this is what I'm plugging in the calculator to find my approximate x value. So x is approximately, we're going to go to Sylvie, and we're going to type it in. And we have alpha window, and we have log base 3 of 102 outside of the parentheses minus 1. There we go. So we get 3.210. You got it? You cannot do anything to the power until it is free. All right. This was in your last box. We're going to kind of quickly do it together so that we can have all of our notes done. You'll have all the tools you need to be great. So in the last box, we're going to solve this using change of base. All right. So we're going to set it up as change of base. But first, we got to do what? Make it by itself. So what am I doing? Plus 156 to both sides. So that gives us 4 to the x equals 256. We would take the log of both sides, correct? The log base what? 4. Log base 4. What I do to one side, I do to the log base 4. This sets it free. So now we know x equals log base 4 of 256. We're going to pretend that I don't have a calculator. Oh no, what do I do? We need to remember, it's the log of the argument. So log of 256 divided by the log of the base, which is 4. So in my calculator, this also means that I don't have to press anything but log. So I'm going to type in log of 256 divided by log of 4. And it says the answer is 4. Uh-oh. Equals 4. And what that means is that 256 is a power of 4. Because notice is exactly 4. So that means that 4 to the 4th power equals 256. So your answer is 4. All right. So you have all the tools and brain power to be great and have this done by next class. It should take you approximately 20 minutes on this assignment, which would be something great to do during when? Or lunch if you want to multitask.